Okay, so we're going to cover the work-kinetic energy theorem. And the first thing we want to start with is what work is. So remember, work is going to be the amount of force in a direction of displacement. So that would be some force dotted with a displacement dr. Now, if we want the net work done, what we're going to do is we're going to add up all the forces along infinitesimally small increments of our position. So that's going to motivate us to write that the net work is the integral of f dot dr. And then from here, we're going to use Newton's second law, F equals ma, to rewrite our f. So this will give us that the net work is going to be the integral of mass times acceleration dotted with our displacement dr. And then from here, we're going to do a small change in variables. So this dr here can actually be written as v dt because our velocity, remember, is the first time derivative of position. So this will give us that the net work is the integral of mass times acceleration. And then we're going to rewrite this as v dt. Okay, and then our dt here, we can rewrite this again. Now, remember that dt is going to be so what we'll do is we'll write it as dv over a. So that's what dt is equal to. And the reason is because that acceleration is, remember, the first time derivative of velocity. And then what this is going to do is it's going to cancel out the accelerations, giving us that the net work is mass times velocity times the change in velocity. And then this is going to be evaluated from some initial velocity to some final velocity. And then carrying out the integration, we find that the net work is going to be 1/2 mv final squared minus 1/2 mv initial squared. And this guy here, this is our work-kinetic energy theorem, stating that the net work done on an object is going to be equal to its change in kinetic energy. Okay, so we know what the work-kinetic energy theorem is, but now we actually should practice it and applying it. And so I have here written out an example that we're going to go over. 3 parts A, B, and C, where we're finding the total work done over these 3 different paths. So path A, evaluated in 2 parts. So the whole thing is O to P, but we first go from O to Q and then from Q to P. So looking up top, we have our general equation for our work. And for part A, splitting it up into 2 parts, it's going to be from 0 to 1. And then we'd have f of x, and then we change in the x direction. We're at 0 in the y. And then similar for this one, but instead we will be at 1 in the x, and then changing y. Now, actually putting in our thing for f, x squared, and then 2xy, we find that we'd have 0 to 1. This would just become x as x squared dx. Here, integral from 0 to 1, our f of y becomes 2 times x times y dy. Now our x in this is just 1. So our x value down here will simply take on the value of 1. Solving and evaluating these integrals, this will become 1/3 x cubed evaluated from 0 to 1. And then this is plus y squared evaluated from 0 to 1. This will give 1/3 plus 1, giving us a total work done of 4/3. Okay, now part B. So here we have the path 0 to P. We're going to take the general form first of fx dx and plus fy dy. Now here we're given this relationship, which we will use, and that's going to give us integral from 0 to 1. All of this is the origin. This is 0.11. Hence the 0 to 1 integral in A, and then the 0 to 1 in part B. So this will give us x squared, and then we will have 4x to the 4th. And that will be dx. And then we can split this up into 2. So x squared dx, 0 to 1, 4x to the 4th dx. Evaluating these separately, we already know what this turns into. We did it up top for 1/3 x cubed, 0 to 1. And then this will become 4/5 x to the 5th, evaluated from 0 to 1. Okay, this will give us 1/3. This will give us 4/5. That is in total going to give us 17 divided by 15. Okay, and then the final path in this example, we are given this relationship, which we will use. So x equals t cubed, y equals t squared, and then our dx and dy will be rewritten. So our dx will become 3t squared dt, and our dy is 2t dt. Okay, and then, so if we substitute those in for our f dot dr, we will have t cubed squared. So this is the x, and then this is the dx, so we'd have 3t squared dt, and then our y would become 2t to the 5th dy 2t dt. And then using this in our work equation, it's the integral 0 to 1, and then we will have 3t to the 8th here, plus 4t to the 6th dt, I believe. Yep. Okay, and then again, we can split this up into two integrals, 3t to the 8th dt plus integral 4t to the 6th dt. And then this becomes 3/9 t to the 9th from 0 to 1 plus 4/7 t to the 7th from 0 to 1. And then this is simplify. So this will just become 1/3 plus 4/7. That becomes a factor of 21, so that becomes 19/21. All right.